Yeah, anyone? What is the meaning of ism, guys? Iso means same, mer means molecule, ism means some group of qualities we know. Yes or no? Some group of qualities are called as ism. Yes or no? So some group of qualities. So molecules which are having group of qualities, or we can say properties, ism means. Yes or no? We can take in that sense also. Molecules which are having similar properties. Yes, sir. Molecules which are having similar properties. We're creating some new words, Mr. Surya. Okay. Molecules which are having similar properties. What is the similar properties means? Maybe they're having same molecular formula and they're having different properties. It's like molecular formula is same and the properties are different. Same molecular formula with the different properties. That is called as isomerism. Okay. Same molecular formula with the different properties. That phenomenon is called as isomerism. We'll go a little bit deep. If you take the classification, actually it is two types. Isomerism, if you take the classification, okay, it is two types, guys. One is, yes, come on, you people only. Constitutional or structural isomerism. Yeah, constitutional, or we can also call it as a structural. This is stereo. Structural, guys, stereo. Yes, morning. We can say structural isomerism, and one more is stereo isomerism. Yeah, in the structural, again we have different types. What is this physics coming in this? Okay. In the structural, we have different types. If you take these structural, guys, again in the structural or constitutional, we have different types. Can anyone tell what kind of things are there in the structural? They are like in the structural, under structural we have the chain isomerism, position isomerism, yeah, functional isomerism, functional, yes, we can take ring chain, okay, and tautomerism. Okay, chain, positional, functional, ring chain, tautomerism, and one more also we have that is called as metamerism. Previously, we used to consider like ring chain and functional both are same only. Right now, we have like differentiated. These are the like further branches, like further. This is the further classification in the structure. We have chain, position, functional, metamerism, ring chain, and the tautomerism. These are different types in the structural isomerism, guys. Yes, sir. Sivacharan? Good. Come to stereo. In this also we have further classification. Actually, this stereo can be classified into two ways. One is conformational. Conformational, we'll see clearly what are these. And one more is configurational. Configurational. Conformational and configurational. Again, in the configuration, we have two types. Yes, you were saying, they are geometrical isomerism, it's geometrical, and one more is optical. Yes, no? So, these are this is all about the classification of isomerism. First of all, entire isomerism can be divided into two parts, structural, stereo. In the structural, again, chain, positional, functional, ring chain, metamerism, tautomerism. In the stereo, conformational, configuration. Again in the configuration, geometrical and optical. This is the entire classification, guys. I hope you know clearly, but just we're taking introductional part, classification. Now we're going to start the first one, chain isomerism. Exactly, you tell me, you people already know one word, that gunshot word we want. What is chain isomerism? Keep adding chain isomerism. Exactly that one point we did. Exactly. Chain isomerism. They differ in what? Branching difference. Shalina. Okay, anyone else? Yeah, change in methyl position. Only can we define like that? Only methyl position like that. Huh? Branches differ. Okay, more clearly. Same molecular formula. That's fine. Same physical formulas, different the physical chemical. No, it's not like that. We can say for entire isomerism like that body. Exactly. What is the meaning of chain? Anyone else? Same molecular formula. Yeah, right. We can take this point. They differ in. They differ in connectivity. They differ in connectivity of carbon chain. They differ in the connectivity of carbon chain. Okay, if I say carbon chain, maybe keep in bracket, maybe that is the main chain or branched chain, whatever it is. Main chain or branched chain. Main chain or branched chain. They differ in the connectivity of carbon chain, maybe main chain or branched chain. Okay, they differ in the connectivity of carbon chain, maybe in the main chain or branched chain. That is called as chain isomerism. Yeah, main chain. We can also call it as parent chain. Yes, yes, yes. Now, see, while going, you'll get more clarity. If I take C4H10, you try to tell how many isomers are possible for this. C4H10. Yeah, here I'll tell you one systematic approach, guys, so that you won't miss any isomer. Generally, we can find out, but systematic approach is important. That's what I'm going to tell you. Yeah, to exhibit this chain isomerism, there should be minimum 4 carbon atoms. That's the main point. Yeah, Raja is telling 3, Akshita Sri 4, okay. Sanjay is telling 3, fine Sanjay. 2, okay. Remaining people. Yeah, please, you already know this all, please participate here. C4H10, first I am taking this as systematic approach. Janani, yeah, see. First I am taking it as 4 plus 0. What does it mean is, I am keeping 4 carbon atoms in the main chain, no carbon atoms in the parent chain. That's what I am doing. My God, first question only you are giving wrong answers. People, everyone almost, everyone gave the wrong answer. Most of the fellows. Ramachandra, no, 4 wrong answer. Okay, 4 plus 0 means 4 carbon atoms in the parent chain or main chain. There are no branch chains. The next one is 3 plus 1. 3 carbon atoms in the main chain. Samir, absolutely no, wrong answer. And 1 carbon atom as the side chain. 3 in the main, 1 as parent. So this is N-butane, this is isobutane. Apart from that, you tell me any other possibilities are there to get the 4. So if I take 2 plus 2, for example, I'm keeping 2 in the main chain, 2 in the branch chain, 2, 2 like this. It is nothing but this only. So same structure should not consider. So total number of isomers are 2 only. Please. Almost everyone gave the wrong answer. So my God. Yes, no. So it is not. So total will get the 2 isomers. Yes. Sanjay. So for C4H10, total possible chain isomers are 2 only. Very good, Manu. Yes, yes. Samir, please focus properly. 4 plus 0, 3 plus 1. Yeah, if I take everything should equals to 4. 4 plus 0 is possibility. Next 3 plus 1. Next 2 plus 2 is also 4. I'm equating to 4 everything. But here 2 carbon I'm keeping like this, and remaining 2 I'm keeping like this. Total it is also N-butane. Already we wrote no N-butane. No need to consider 2 times. So that's why we should not take that. Got it all. So we should not consider same structures. No, you know that. To find out whether it is same or different, you try to give the IUPAC name for that. This is N-butane, this is also N-butane, both are same. So that's why we should not take. Yes, sir. Where is Mr. Sai Kumar? He is not there. Samir, understood? These are only the possibility. You can check all the possibilities. In the whatever way you just want to write, you can write and check. How to find out whether it is same or different means you try to give the IUPAC name. If you get the same thing, you should not consider. That's it. Sanjay, very good, Sanjay. Crystal clear. Nice. Yeah, like that word. Fine. Come to the next one. I'm giving now. I think you people understood in what way we need to approach. Then do guys. Systematic approach is more important. You can write the examples, you can tell the answer, but always you have the time. You have the doubt whether it is right or wrong. Okay, did I consider all or did I miss anyone? To overcome that kind of doubt, I'm giving this systematic approach. Simply you can get. Yeah, Zubair, can you explain IUPAC names? IUPAC names also you want to, it takes so much time. Okay, right now maybe, yeah, wherever we're getting this compound names, I'll give the names. Okay, there we'll see. Yeah, if you have time, then we'll see that also, Mr. Zubair. Yeah, Akshita's 3 is giving 3. You can find out here, this follow, you'll get it. 3, yes, Srinayan, 3, yes, everyone is giving right answer. Nice. Now come to that systematic approach. Yes, Janani. Okay. Oh, Shalina, fine. 1, 3 submission. Good. Now come to the systematic approach is more important. You're getting answer, that's fine. But here approach is more important. I can take like this. See, first one, I can keep 5 plus 0. What does it mean? All carbon atoms are in the main chain only. There are no branch chains. Yes, Swati, nice. 1, 2, 3, 4, 5 ways. What is the next possibility? 4 plus 1. 1, 2, 3, 4. I'm keeping 1. If I keep here or here, it doesn't make difference. Yeah, for example, this is what? One more possibility. Maybe you can think like this. I can keep here also. I can keep like this. But both are same. What is the name? This is N-pentane. This is 2-methyl-butane. This is also 2-methyl-butane. Both are same. There is no difference. Yes or no, guys? Both are same only. There is no difference. So don't take this one. 4 plus 1. Next, can we take 3 plus 2? You just check with the 3 plus 2, 3 carbon atoms. I'm keeping 2 here. It is nothing but this only. 3 plus 2, see 1, 2, 3, 4. It's nothing but 2-methyl-butane. So again, same thing, no need to consider. Next, this 2 is there, no, I'm further classifying that also, 3 plus 1 plus 1. Here I'm 1, here I'm keeping 1. Now, what is the name? 2 comma 2 dimethyl propane this is. So this we can consider, this we can consider, this we can consider. Total we got 3 isomers. Hope you got it. Understood? The approach is more important, guys, in what we were doing. Akshita, good. Just practice like this. Maybe the first or second time you'll feel difficult. What is this 5 plus 0, 4 plus 1? But after some time, you'll be okay with that. Okay, automatically you'll get that. Yes, sir? Good. Fine. Come to the next one. Okay, Sanjay, fine, nice. The next one is we're going to take C6H40. Yes, guys. Okay. Yes, Sanjay. Fine. Yeah. Just the approach is very important, guys. In the same way, just right. How many possibilities are there? You just take all this. Raja, you try. That's what. Don't tell like that. You try all the possibilities. Maybe initially you will feel a little bit difficult to write all, but you will have it yet so that you will get the confidence you are not missing anything. That's what we want. Akshita, just try properly. Manjari, that's fine. Right answer. I hope you write all. Shalina, yes. Akshita, you try for more. Swati, fine. Yes, Srinayan, Moni, very good. People are doing well. Remaining people. Yeah, Mr. Adi, good. Yes, Akshita, fine. Yeah, okay, guys. Sivacharan, yes, Raj, I got it, huh? Good. Now, same thing as you have to like approach in a systematic manner. The first one is 6 plus 0, I'm taking. Like this. It is the 6 plus 0. Okay, what is the next possibility? 5 plus 1. I'm keeping 5 like this. I can keep 1 here. This is 2-methyl pentane. This is N-hexane, 2-methyl pentane. And one more possibility, like this, guys. This is 3-methyl pentane. Yes, 2-methyl pentane, 3-methyl pentane. Okay. And we can't keep here. If we keep, that's also same. Next, 5 plus 1. We can take 4 plus, next possibility, 4 plus 1 plus 1. Okay. Like 4 plus 2, if you take 4 plus 2, yeah, it is a 4 plus 2. Wherever you keep, either here or there, 2 carbon atoms, it is nothing but this only. If you keep here, it's nothing but this only. So that's why we no need to consider. Okay, already wrote. Now come to this 4 plus 1 plus 1. The 2 is there, no. This also you break further. You practice like that. Maybe first time you're listening a little bit difficult, but thing is you won't miss anything if you approach like this. Okay, very important this method is. 4, 1 plus 1. So wherever we are getting 1 plus 1 like that, first possibility is keep both on same carbon atom. This is 2 comma 2 dimethyl butane. The different name. And next one more we can write for this. 1 here, 2 comma 3 dimethyl butane this is. Another possibility. So like that, we have the entire thing. Yes, sir? So total how many we got? Total we got the 5. 5 should be with the different names, guys. Then only we can consider like this. Shrinayan. Okay. Very good. I hope you did it. So total we got the 5. Next. Take the next example, guys. You finish it. If you finish, then we'll move to the next one. C7H16. Try to write all the possibilities. If you write all the possibilities, almost you're okay with that to find out. Yes, you finish it, guys. I hope you understood for the C6H14. Now C7H16. That systematic approach is important. You can get the answer, that's fine, but the approach is more important so that you won't miss anything. Here, you need to practice this one. You will get the confidence, guys. I'm writing all because you'll only come to know that whether you're touching everything or not. That's what we need. Yes, Manjari. Bhavanu, very good, very good. Yeah, fine, correct. You practice in that way. Systematic approach, Shalina. Good. Oh, Shinayan, very good. Samir, nice, nice. People are giving right answer. Very good. Good. Remaining people, guys. Tejasvi. Yeah, very good. Yes, right answer. Vani, very good, guys. Very good. Everyone is giving right answer. Nice. C7, then C. The first one is, we know that as usual, 7 plus 0. I'm keeping 7 carbon atoms the same. Like this. 7 plus 0. Yeah. I'll tell you. Next, 6 plus 1, guys. We can keep here once. 2-methyl-hexane. Okay. Next one is like this. We can keep here. This is 3-methyl-hexane. So 2-methyl-hexane, 3-methyl-hexane, second possibility. The next one is 5 plus 2. I can take like this. This is 2-ethyl pentane. Okay. Next, 5 plus 1, guys. So you take the 5, 1 here, and 1 here, and please see here in what way I'm writing. 5 plus 1, and 1, 2, and one more, 1, 3, guys. So total how many possibilities we got? 1, 3, 4, 4, 8. Okay. The next, I think one more also we have, that is 4 plus 1 plus 1. Okay, apart from that, nothing we can get. And one more with this is, yeah, 4 plus 1 plus 1 plus 1. 7 we need to. 1, 2, 3, 4. Like this. 1 here. So these are all the possibilities, guys. 9, I think we got, see there, 1, 2, 3, 4, 8, and this is 1. Total we got the 9 isomers for that. Yeah, here for number of isomers particularly we don't have a formula. Okay, because we can include geometrical, optical, like that. We don't have formulas, and you can, we will get the right answer with that. Okay, better don't go with the formulae. Remember the concept. We have formulas for geometric isomers, optical isomers, not for the chain. But there is simple logic to remember. It's not a formula. Remember for the only chain isomers. Okay, if there are two carbon atoms, sorry, if there are four carbon atoms, we'll get the two isomers. Five carbon atoms, three. Six carbon atoms, five. We have seen already. Seven carbon atoms, nine. Eight carbon atoms, 18. Nine carbon atoms, like 35. 10 carbon atoms, I think 75. This kind of shortcut we have. Okay, we have to remember only, guys. Mostly they won't ask up to that. Up to 7 carbon atoms, they'll ask. You can practice like that, and you can get the answer. Yes, sir. These things no need to remember. Next, not only for the open chain, we can also take with cyclic also, right? C6H12. Write the number of isomers with the cyclic compounds. The cyclic with the cycle like C6H12 with ring compounds. Write the number of isomers. Not only with the open chain, we can do with also ring, guys. Just try to write the isomers for that. Try to write all the isomers for that. Anyone? Akshita, no, no. Remaining people. No, Manjari, try for more. Try for more. Like, try to explore more like structures. Shinayan, wrong answer. C6H12, you can write all the possibilities. Please check for that. Think for more possibilities. That's what. Remaining people. Yeah, Sanjay, what is the answer? Yes, yes, Mr. Raja. Anyone else? Shalina, I'll get more than that. Yeah, okay, guys. This I'll tell you the first one. Later you can do. First, as usual, we are writing this is 6 plus 0. 6 carbon atoms in the main chain, there are no substituents. After that, I can also take this, no? 5 plus 1, this is called as 5-member ring and 1 carbon atom. This is the 5 plus 1. After that, I can also take like this, 4 plus 2 it is. See in what way I am writing. 6 plus 0 first, 6 carbon atoms in the entire ring. 5 plus 1, 5 carbon atoms in the ring, 1 is as substituent, 4 plus 2. I hope you can understand. Apart from that, we can write this also, 4 plus 1 plus 1 it is. Like this, 2 substituents. And one more also we can write for the 4 plus 1, okay. Yeah, I can write like this 4 plus 2, 4 plus 1 plus 1, this is. I can also write this one, 4 plus 1 plus 1. One more, 4 plus 1 plus 1. These are all the possibilities, guys. Okay, till now how many we got? 6 we got. And we have still one more, third, three-membered ring, no? Your understanding? Yeah, come to three-membered ring. So 3 plus 3 possibility, I'm taking a three-membered ring, guys. I'm taking a three-membered ring and 3 carbon atoms as a substituent. And we can also take this one apart from that. Yes, sir? 3 plus 3. Next, 3 plus 2 plus 1 also we can take now. 2, 1 here. 2, 1 here. Next, 3 plus 1 plus 1. So 3-membered ring, 1 here, 1. 3-membered ring, 1 here, 1 here, 1 here. See total how many possibilities we got? You can find out no way the structure got repeated. So total here we got the 6. Here 6. Total we got the 12 structures, guys. Yes, sir. That's what we need to explore more. Is there any other possibility? Okay, like that we have to check always. Probabilities. With the total number of carbon atoms, how many possibilities we have? In what way we can write all these things? That always we need to check. Yes, Mr. Shankar, hi. Good evening, everyone. Yeah, you came so late. We have done almost some isomerism. Shankar, thank you. Thank you. Your comments will give more energy for me to give you my best. Thank you, guys. Shalina, why are you laughing? Okay, there are. Okay, fine. Fine. Okay. Yeah, and one more thing, you will get some. Oh, Sanjay, thank you. Yeah, for this we have to write all these guys. Okay, this is like a little more than the mains level. This many things, somewhat easy questions only they are asking in the main. So only rarely they are asking this kind of tough questions. And one more thing I'll tell you, then we'll close this. Yeah, you please remember this kind of things. For example, if it is like this and these two, if I'm remembering, yeah, these two are also chain isomers. So the main thing is, yes, okay, JK sir, fine. The main thing is they should, the main chain is same. Okay, the substituent, this chain isomers we can take, this we can call it as 5 plus 2, no? This is 5 plus 1 plus 1. So both we can call it as chain isomers only. And we can also take with the benzene ring. You may get confusion in the final. This we can take it as chain isomer or not. These two also chain isomers. Okay, man. Okay, fine. Yeah, please come here. Okay, just it's one word. Go on. Don't be there only. Just come to the subject. So these are all we can take it as chain isomers. Okay, by seeing sometimes you'll get the confusion. Can we consider them as chain isomers or not? But remember this also, because see there here ethyl, here dimethyl. So this is also 6 plus 2. We can take this is 6 plus 1, 1 plus 1. This also comes under chain isomers only. And this is guys all about the chain isomerism. Till now, if you have any doubt, you can ask. This is all about the chain isomerism. You need to practice the systematic method. Practice 3 or 4 times. You'll get idea, so that you will write on your own number of isomers. Okay, if you write like that, that's really, guys, that's the next level for the organic chemistry. On your own, you're creating the structures. Good. Completed. Yeah, please type C if you complete, guys. We have that shortcuts now. Okay, fine. Yeah, fine. Yes. Come to the next part, position isomerism. Fine, guys. Position isomerism. It's very simple. Right, guys. Differ in the position of clear simple thing. Like it's differ in differ in position of maybe functional group. Yes or no, guys? Functional group or double bond or triple bond or any alkyl group or alkyl group like substituents. So it's simply about just by writing, just by seeing, we can identify by the position, at what position. Okay, that's what it is about. See, I'm giving one simplest examples, easily you can identify. I'm taking the butane, guys, or simply I'll take pentane. I'm keeping chlorine here. This is 2-chloropentane. Next time I'm keeping chlorine here. This is 3-chloropentane. 2-chloropentane and 3-chloropentane. Here it is about 2 and it's about 3. I'm changing the position. Here 2-chloropentane, 3-chloropentane. Exactly, the difference is position only, no? So that's why both can be called as a positional isomers. Simple, quite simple thing it is. Okay, and we can also take this kind of thing, 1 butene. We can write for this 2 butene. That's it. Double bond or triple bond. Okay, we can take the functional isomers, whatever it is, alkyl groups, all these things. Just like that, guys. Positional isomers. Okay, so we can keep one more thing. Yeah, we can write alkyl groups, no? If we take like this, same, 2-methyl pentane, and this is about 3-methyl pentane. Both also comes under position isomer, just changing in the position. That's it. Yes, sir. Come to the next part. Yeah, here also, just before we have seen, methyl groups are there on the benzene ring. 1,2 it is, 1,3 it is, 1,4. These are all position isomers. Yes, no. I think we know this is called as ortho, and this is meta, this is para. Further, we'll see more clearly. These are the different isomers. This is all about simply position isomerism. I think you all know very well. Next, come to the next part, functional isomerism. Functional isomerism. Yes, sir. Yes, Trinine. Yeah, here some groups are there. We have to remember exactly what we can take it as the functional isomers. Just remember that. First one, enes and cycloalkanes are the functional isomers. First category, guys. Ene and cycloalkane. These two are functional isomers. See there, I'm taking this one, ene and cycloalkane, this one. Both are functional isomers. See, you can check the number of carbon and hydrogen atoms. That is the fundamental thing. Okay, we should not cross that. The number of carbon and hydrogen atoms means the molecular formula should be same. Then only we can write the other forms. You check there. CH2, 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 C3H6, and here also same thing, C3H6. Alkene, cycloalkane. These two can be considered as functional isomers. Yes, sir. Is everyone okay with that? Functional isomerism. Sanjay, are you there or not? Shinayan, yes. Next, that is the first one. And take the second one, guys. Ine and dienes. These are also functional isomers. So we can take the ine. For example, we are taking like this, butane it is. And if you consider diene, this is going to be like this. Here double bond, here double bond. Ine and diene, both are the functional isomers. Esa. Next, third category, alcohols and ethers. These are also functional isomers. I'm taking the alcohol like CH3, CH2OH, ethyl alcohol. I'm taking CH3O, CH3. Yeah, Zubair, you asked for the IUPAC name also. No? See, OH is there and two carbon atoms. You know, two carbon atoms means ethyl alcohol. For ethers, how to give the name? Diethyl ether it is. Yes, Samir, diethyl ether. If you go for a little bit IUPAC name, we can consider like that. Alcohols and ethers. Esa. Alcohols, ether. Ether can be called as diethyl. This is like methyl, dimethyl ether it is, sorry. Dimethyl, methyl groups ether. Yeah, just follow like this. We'll get wherever possibility. We'll see that also. Next one, guys, you take care here. Generally, you'll go wrong. The fourth one is like aromatic alcohols, phenols, ethers. These are all functional isomers. Aromatic alcohol means we can take like this, no? Aromatic alcohol, CH2OH. And phenol, just phenol. The molecular formula should be same, guys. You should not go from that. And ether, this is what? Alkoxy-alkane, IUPAC name is like this. See, they're everywhere. The number of carbon and hydrogen and oxygen atoms are the same. Remember, phenol is not aromatic, like we should not say aromatic alcohol. Phenol is a different, it's a phenol. We should not consider phenol as aromatic alcohol. Please remember this point, guys. Phenol is phenol only. It's not aromatic alcohol. This is the aromatic alcohol. It's a different functional group. You treat like this. Generally, we have that kind of thing in the mind. It's aromatic alcohol. No, it's phenol. This is what aromatic alcohol, and this is the difference between the two. Aromatic alcohol and phenol. Please write that point. Write that point better. Later you'll forget that. Phenol is not aromatic alcohol. It's just phenol. That's it. Phenol is not an aromatic alcohol. Please write that point. Phenol is not an aromatic alcohol. Yeah, Suman, from that we can get mostly 2 or 3 questions. From the alkenes, surely we'll get the 1 question. From the alkanes and alkanes, 1 question. Mostly 3 or 2 will get. And from benzene, 1 or 2 questions will get. And that's not only from benzene. To get the second year, they'll connect with the benzene, like aromatic compounds. There we need to know about the benzene. So from the benzene, 2, 3 questions we'll get. That Friedel-Crafts alkylation, that all things we need to see. Yes, sir. Yeah, Sumant. Completed up to this. Come to the next point, guys. We can take it as aldehydes and ketones. These are also functional isomers. Aldehydes and ketones. Please focus here. Okay, if we take the aldehydes, what we can take is CH3, CH2, CHO. Propanol, it is all. CHO group is called as all. Okay, and ketones means, yeah, we can take on ketone, propanone, guys, it is ketone. I can write like this. Propanol, CHO is called as all, and ketone, C double bond is called as ketone function group. So this is propanone, this is propanol. We can say like this. Yes, Suman, as much as possible, I'm covering now. Actually, in the chemical bonding, we have to finish in 2 classes, but I've taken more than 3 because surely we'll get the 2 or 3 questions from that. So wherever the more importance is there, I'm giving automatically more focus on that. Yeah, sure, I'll do. Good. Please focus here. Later we'll talk all this. Next, come to the 6th one. You have to remember all, guys. Carboxylic acids and esters. Right? Carboxylic acids and esters, guys. Carboxylic acids and esters. So carboxylic acid and ester, if you consider at any carboxylic acid, CH3, CH2, like CH2, COOH, I'm taking carboxylic acid. With that, I'm writing an ester, CH3, CH2, C double bond O, OCH3. Whatever it is, the number of carbon atoms, hydrogen atoms, oxygen atoms should be same in both structures. Now, 4 carbon atoms are there, no? For the IUPAC, in the sense of IUPAC, I'm talking 4 carbon atoms, but acid is called as, like OE, COH is called as. So this is called as butanoic acid. Now come to this one. If it is ester, first of all, we have to mention the alkyl group which is attached to the oxygen. So this is methyl. Remaining how many carbon atoms are there? 3 carbon atoms. So prop. Ester is called as OH. So this is called as methyl propanoate. Methyl propanoate. This is butanoic acid. Getting clarity, guys? Methyl propanoate. This is methyl propanoate, and this is butanoic acid. Yes, sir. Next, nitro and nitrite. Both also we can take. 7th one, nitro groups and nitrite, guys. So if it is RNO2, see the connectivity, the nitrogen is connected with the R group, like carbon, and RON double bond O. Here, alkyl group is connected to the oxygen. If it is nitrogen directly, it can be called as nitro. If it is with oxygen, that is called as nitrite. That's the difference. See carefully the connectivity, guys. RN, RO. Hope you got it. Yes, sir. Next, 7th one. 7th one, 8th one it is. 8th one is cyanide and isocyanide. Cyanide and isocyanide. If it's cyanide, RCN, guys. Isocyanide, RNC. Again, see the connectivity. Carbon is with the carbon. Alkyl group is with the carbon. That is called as cyanide. Alkyl group with the nitrogen, isocyanide. Yes, cyanide and isocyanide. Hope you got it. Last one. This is the previous mains question. Yeah, primary, secondary and tertiary amines. Yeah, primary, secondary, tertiary amines are functional isomers. Generally, by seeing the structure also, we won't feel like that. But this is the previous mains question they asked. Yes, Satvik. That's what we are saying, Satvik. Focus on the important aspects from what they can ask the questions. That's it. Okay, and whatever you know clearly, you revise that only. Don't go for the new topics right now. So that fine. So completely go with the classes. You become thorough with these concepts. We are covering the most important topics. Now primary, second, and tertiary amines. See guys, this is what previous mains question. Previous year questions, P by Q. Primary amine I am taking. See, CH3, CH2, CH2, NH2. Primary amine. Next. Means nitrogen with two hydrogen atoms. That's a primary amine. CH3, NH, CH2, CH3. Nitrogen with one hydrogen atom. One hydrogen atom means secondary amine. Third one is, I'll write here. Third one, CH3, N, CH3. See, everywhere the number of carbon, hydrogen, nitrogen atom should be same. Now, the nitrogen with no hydrogen atom, tertiary amine. Nitrogen with one hydrogen atom, secondary amine. Nitrogen with the two hydrogen atoms, primary amine. These three are functional isomers. Very, very important, guys. Generally, you'll forget this. Please remember this. Is that clear for all? Yes, Zubair, that's what after the class regarding this topic, you practice the previous mains questions you have in the mains, or preparing for mains, or you practice previous MSET questions or previous NEET questions, whatever it belongs to. Regarding this topic, you practice the previous mains questions. Fine, you'll get clarity. Yes, sir. Now I am giving one question, guys. You need to answer it. Shall I give it? Yes, Jubair. Yeah, Suman, that's fine. But you need to cover previous that questions also, please. Next, shall we see the metamerism, guys? Okay, I'll see the metamerism also. After that, I'll give some questions. See the metamerism and the ring chain isomerism, then I'll give some questions. Okay? Yeah. Come to the fourth part, metamerism. So this is simply about the alkyl groups which are connected to the same function group should get deferred. One more time. The alkyl groups which are connected to the same function group should get deferred. The alkyl groups, which are connected to the same functional group should get deferred. So if it is the metamerism, see in what way I am writing the alkyl groups. Like this I am keeping this way. Now this is the ether function group. Here we have ethyl, here ethyl. So this one I can write as methyl and propyl also. That's what it. So the alkyl groups which are connected to the same atom should get deferred. That is the one point. Understood? Next, we can also write like this. See double bond O here, and this one. We can also take it. See double bond O, this one. So here methyl propyl, ethyl. This is what, guys. I hope you are understanding. Yes, sir. Now you try to give me the answer for this question. If I write like this, methyl and this one. Yeah, these two are what kind of isomers? These two are what kind of isomers? Write all isomers, guys. Yeah, anyone? These two are what kind of isomers? See, here alkyl group is propyl, here methyl, here isopropyl and methyl. Alkyl group is differed, but one more thing can be considered as metamers, but before that, see here for the propane it is connected to first carbon, but here it is connected to the second carbon. So this can be considered as position isomers also, because here with the propane, this is connected to the first carbon. No, Raja, how it is functional, man? My God. Both are ethers only, no? Here it is connected to the first carbon atom. Here it is connected to the second carbon atom. So that's why we can consider as a position also. Metamers or positional. When both options are there, highest priority goes to position isomers. You just remember this point. Both will become metamers as well as positional isomers. Highest priority is given to positional isomerism. Good. Now come to the next part, guys. Ring chain isomerism. Ring chain. Yes, Mr. Shanu. Ring chain isomerism. Now, open chain as well as ring, both we need to consider. Like we have seen in the function, no? Alkenes, cycloalkanes, like that it is. So, I've already told you, previously we consider this under function only. Right now, we are like discussing in a separate manner. Now, you write all the isomers for C3H6, guys. How many possibilities are there? You write with the open chain as well as with the cyclic. So the condition, you know, no? Number of carbon atoms, hydrogen atoms, whatever it is, should be same in all structures what we are writing. That's it. Yeah, if you will tell me how many possibilities are there. No, Akshita will get more than that. Okay, first one I'll tell you, the next one onwards you'll get. Yeah, C3H6, this is one possibility. We can write the open chain, no? Propene, and one more is like cyclopropane. Check the number of carbon and hydrogen atoms, both are same in both structures. So total we'll get the 2 for that. Now you got it. Come to the next one. Okay, you write for that. So in the same manner, you write for C4H8, guys. try to explore all the possibilities simply. Right, for C4H8. Yes, Vani, 2. Ashita. For C4H8, how many will get? So here, what is the degree of unsaturation? Means how many double bonds we need to keep? Only one, no? Degree of unsaturation is 1. Because if it is C4, it has to be H10. If it is saturated, H8 means alkenes. DU is 1, no? I hope you know the degree of unsaturation, guys. You tell me how many possibilities we have for Akshita. Akshita is telling 3. No, Akshita, that's what we'll get more than that. Try for more. Dil mange more. More structures we need. Always. Yeah, Kumarasai, this already we have discussed in our classes. Yeah, please check our classes. Same question in the hybridization. That's what I told you. Surely we'll get that. NH4 plus is there in our class. Same models I have covered in our teaching in the chemical bonding. Please check that you will get the answer. That's what I told you. So that's why I've taken more time for the chemical bonding. Almost we did same thing. Yeah, Akshita will get more than that. Bhanu, try for more. Dil mange more. Yes, Raja, fine. Samir. We should take open chain as well as cyclic, both. Ashita. Yeah, see guys, C4H8, no? The first one, I can take like this, like butene, 1 butene, guys, it is. Second one, I can take 2 butene, like this. That's what Kumar Sai, I've already discussed in the classroom, that models, same kind of thing. I have given you so many examples. If you listen that class, simply you can answer. That's what I am saying only. I know they'll ask that kind of question. If you listen to our classes, you can answer it. Okay, I'll tell you. Okay, fine. Let it finish. Next, third structure, like this. Okay, 2 methyl prop 2E it is. Isa? Fourth one, we can take 4-membered ring, no? This is up to open chain. Fifth one is like that I can take. Yes, sir. So how many we got, guys, total? Total we got the 5 structures for the C4H8. Or getting more than that, you can check whether you wrote same or different if it is more than that. How to know whether it is same or different? Means try to give the IPAC name. If the IPAC name is same, then you should end the structure. We should not consider 2 times, that is. That's it. Yeah, Kumar Sai. Okay, for remaining people, I'm giving homework. If people write for that, then we'll see. You write, guys, C5H10. Try to write all possibilities. We have to get that sense. You open automatically write all the possibilities. Okay, this one. Think more. If you think like that, automatically you will get familiar towards organic chemistry. You have that feeling, no, in mind. Organic is difficult. That feeling will go out. If that feeling is not there, surely guys, believe me, you will do the miracles with organic chemistry. Okay. Most of the people are losing marks like that only in the organic. Yeah. Some more after completion of that electronic effects and intermediates, you'll get more clarity to read first year organic chemistry and second year. Yeah, fine. Now you write all the isomers. C5H10, how many possibilities? C. Kumar Sai, what you asked? There are, let me see once. The structures are NO2 minus, NO2 plus, and NH4 plus, no? Yeah. I told you one simple trick for that. First of all, see, NH4 plus it is. What is the valence of nitrogen? 5. Plus means it lost 1 electron. Then 4 electrons are there. With 4 electrons, it's forming 4 bonds. 4 bonds means sp3. Done. See how simple it is. Next, NO2 minus. Nitrogen valence is 5. It is minus means taking 1 electron. Total 6 electrons are there. 6 electrons. But with the 2 oxygen atoms, it's forming 4 bonds, 2 sigma, 2 pi. We should not consider pi, we should consider only the sigma. 2 sigma, 4 electrons are over, 2 more electrons. So 1 lone pair, 2 bond pairs, total 3 means sp2. Like that only I told. Yeah, Akshita will get more than that, try for more. Next, what you're asking, NO2 plus, no? Same thing, nitrogen is having 5 electrons. It's lost 1 electron plus means then 4 electrons, 2 oxygen atoms, 2 sigma, 2 pi. So 2 sigma means 2 BP, 2 BP means sp. This is what. In the same way, almost I gave around 30 to 40 structures. If you listen that class, simply you can answer. I know they'll ask one question surely from this. That's it, guys. Nice. See how simple it is. If you know just group number, you can go for it. Yes, Swati, correct? Good. Yeah, remaining people, Manjari. Or did you keep for that? Whoever wrote exam, please check that. Did you it fine or not? Correct or not? Now, remaining people, please write all the SMS for that. Yeah, Raja, you got the 10. Great, great. Surya, thank you. Yes. Yeah, now you check all the SMS, guys. Good. First one, C5H10. 1, 2, 3, 4, double bond. Because degree of unsaturation is 1 for that. Next, I can keep the double bond position here also. Second one, I am keeping one more, I can write here. So 1 pentene, it is 2 pentene. I can't write 3 pentene. If I keep, that's nothing but 2 pentone. Kumar Sai, fine now. Very good, very good. Now come to the third structure. I can write like this. Double bond here. 2-methyl but1ene. Fourth structure. Same thing. 2-methyl but2ene. SR. Fifth structure, we can write like this. Same thing I am writing, but I am changing the position of double bond. Like that I can keep. So this is 5 plus, like 5 plus 0, these two are same systematic approach. You should not go far away. Okay, not deviate from that. This is about 4 plus 1, 4 plus 1, 4 plus 1. See, in open chain, totally we got 5 structures, guys. To tell me any other possibility with the open chain, not with the ring. Yes? Anyone, guys? Next, come to the ring, about that only. Sixth one is, I'm taking the ring compound, guys, 5 compounds, 5 plus 0. Seventh one is 4 plus 1. Eighth one is 3 plus 2 plus 2. Sorry, 3 plus 1 plus 1. Total should be 5 only, no? Ninth one, I can write that one in this way. Yeah, okay. One here, one here. 10th one, last one, guys. 3 plus 2 it is. Yes. So total we got 10 structures. Only we can't get 11, no? I think total we'll get the 10 only. Any other possibilities are there? No? Yes, I think these are fine. Next, guys, I'm giving one structure. If you write all the possibilities for that, get more clarity about this. Yeah. Yes, sir? Yes, see, guys. Take this structure. I'll see who will give the answer for that. C3H6O. Tell how many isomers are possible for that. So here oxygen is also there. Degree of unsaturation is 1 only. We have to keep 1 double bond. So according to that, how many we can get? C3H6O. Kumar Sai, correct? Good, nice man. Yeah, we are discussing the topics only. We already gunshot topics, that's what Kumar Sai, we are discussing that only. You please follow. We posted in our group also. Okay, some schedule for what I am taking the classes. Some schedule is given. You please focus first of all on that. After that, remaining. Yes, sir. Good. Yeah, now tell me, guys, how many structures we can get for this? C3H6O. Anyone? I'm waiting for your response. Swati. Yes. Yeah, if it is C3H6O, first of all, I am giving one structure. Based on that, you will get more clarity. First one, I can take like this, no? So I'm writing this kind of structure, guys. Please be aware of that. Yeah, I'm taking the all calls. So you first O is there, no? Remember, this is the simple thing. One oxygen atom is there always. One oxygen atom. If degree of unsaturation is 1 oxygen atom is there, means we can always get the alcohols. So first of all, I'm keeping just write like this. Write all the alcohols. That is the first possibility. Yeah. So one more with alcohols only like this. So one oxygen atom is there. Simply we can write the alcohols. Next, one more thing. This kind of alcohol. So with the 3 carbon atoms and double bond. 1 carbon atom, we can always get the alcohols. This is what it is, first possibility. Alcohol system. If it is alcohol, automatically we know that ethers also possible. No, I am writing all ethers. That is like I can take in this way. Ether is done. So I have finished alcohols. Now I have finished ethers. Now remember guys, just by seeing how to identify what kind of structures we'll get, basically you need to have that idea. Okay, this is what the formula. Based on that, what kind of compounds we may get. First of all, you need to think like that, then you start to write. One oxygen atom is there, we can get the alcohol, we can get the ethers. Degree of unsaturation is 1 and still one oxygen atom, then fine, we can get the ketones as well as aldehydes. Now come to that only, that also. Okay, so we can write aldehydes after that. I can write aldehydes. Okay, so this is what guys, aldehydes. Next, if it is aldehyde, we can write ketone also, no? So what is the ketone with that? This is the ketone. Next, we can write the cyclic ethers, guys. First, think all the categories. This is what cyclic ether, and this is what cyclic ether. This is also cyclic ether. These two. Next, if it is cyclic ether, we can also write cyclic alcohols. No? Yeah, Kumar Sai, we posted in the group. It's there already. You go with the topics. Like this, OH, cyclic alcohol, SR. So that is the cyclic alcohol, guys. We can get that. So now, tell me how much total? 4 here, 2, 6 total. We got the 9. Now, guys, listen carefully. I am giving one question. C4H8O. If you write all the isomers for this, you are okay with entire isomerism. How to write the isomers? Not with the, like stereo, you are okay with the chain, apart from the tautomerism. So you write all the isomers C4H8O. Whoever is finished, if you tell all the number of isomers, I'll give one nice gift to you. Yeah, really, I'll give you. We have your details, no? I'll give a nice gift if you write all the isomers for this C4H8O. I told already for C3H6O, no? According to that, you just write. Whatever the possibilities, same possibilities, but the number is different. Okay, we can get alcohols, we can get ethers. I'm only telling, we can get aldehydes, we can get the ketones, we can get the cyclic ethers, we can get the cyclic alcohols. But the number is different. You try to write all the isomers for the C4H8O, then entire thing is done. You are okay with the isomerism. I'll send you a nice gift to you. Yes, sir. Okay, guys. Thank you. Nice class it is. We'll meet in the next class. Okay, please practice. Okay, like radio, you're listening and going, it won't work out. You have to practice enough. So right now, I feel you're getting the nice content. Please practice enough number of times so that you'll get more clarity, guys. Okay, fine. We'll meet in the next class, and that have a nice time. Thank you, guys. Yes, Surya. Adi will get more than that. Please practice for more.
పిల్లలకి పాపం ఎగ్జామ్ టైం కదా, మెయిన్స్ రాసిన వాళ్ళు బాగా మీకోసం ఎక్స్పెక్ట్ చేస్తున్నాను. పగలేదన్న టైంకి వస్తానని చెప్పండి. నా క్లాసులు కావాలంటే ఆపేస్తాను. వచ్చేసే 2కి వచ్చేసే కావాలంటే 2 to 3:30 కానీ 4 వరకు తీసేసుకో. రైట్.